So the article that we read is about academic language and the EdTPA. And first of all, what exactly is academic language? The article described it as oral and written language used for academic purposes. Academic language really helps engage students in learning, and it can look and be different based on what subject you're studying. I personally think academic language is very important in the classroom, both for the teacher and the students. From the teacher's point of view, it's important to understand the academic language so that you can teach your students to have a good understanding of that language and to use it in your classroom. So some steps from that EdTPA handbook. They have one, identify a key language function, one essential learning task within the learning segment lesson plans that has students practice the specific function that you choose. And then identify vocab and one additional language demand related to the language function and learning task. And then identify and describe the instructional and or language supports they have planned that are planned to address the language demands. And then some language supports include scaffolds, representations, and instructional strategies that I, as the teacher, will intentionally provide the student. Now, it's important here to know that not all learning tasks focus on both discourse and syntax. You have to use the most relevant language understanding to the learning task. And then, as the teacher, I want to provide appropriate and targeted language supports. So the language supports basically have you identify a language demand and then you tailor those supports towards the demands. And personally, I just think this is really important because the language supports can help students come to better understand the importance and overall use of the language demand that they're using. And then there are 5 different language demands in this subject of secondary mathematics, and those are listed as function, vocabulary, discourse, syntax, and mathematical precision. And language demands are clearly very important. They're important to understand and use in the classroom because they help students have a better knowledge of the subject. And I also think a better and deeper understanding of the different aspects of the subject itself. So in this particular case, in the case of secondary mathematics, the first one we have is functions, and the definition of that is purposes for which language is used, which in other words is also content and language focus of learning tasks typically represented by active verbs within the learning outcomes. So some examples of that are comparing, specifically comparing the lengths of sides of triangles. So comparing is different than using another word for that. Comparing has that specific function. And then another example is describing, not comparing, describing this time, the attributes of an isosceles triangle. So if I were to ask a student to describe the attributes of an isosceles triangle, they wouldn't be comparing an isosceles to an equilateral triangle. They would be saying an isosceles triangle has 2 sides that are same and 1 that is different. They wouldn't be saying, well, it has 2, but an equilateral has 3 equal sides. The second language demand is vocabulary. And so the definition of that basically is words and phrases with subject-specific meanings that differ from meanings used in everyday life. So this is really important in math because math often does have a lot of different words that they do end up having different definitions in the math area than they do when you're using them in everyday life. So some examples of that are table, face, and chord. So the face, normally you think of your own face, but a face in math is like a face of a shape or a graph. And then general academic vocab used across disciplines. So examples of these are describe, compare, and analyze, like we just talked about, describe and compare. So you can use those in other areas as well. And then subject-specific words and or symbols defined for use in the discipline. So these are things like numerator, isosceles, exponent, words that specifically come up in math that you probably wouldn't typically see somewhere else. The third one is discourse. So this is how members of the discipline talk, write, and participate in knowledge construction using the structures of written and oral language. And then discipline-specific discourse has distinctive features or ways of structuring oral or written language or representing knowledge visually. So some examples of this, interpreting graphic representations, and then also constructing an argument using a two-column proof. So a lot of times in my math classes, we write a lot of proofs, and that's just an example of how we as mathematicians talk. And this is just very important in the classroom because it's different than what you might normally see in another classroom or just in everyday life. The fourth language demand is syntax. So the definition of this is the rules for organizing words or symbols together in phrases, clauses, sentences, or visual representations. So a couple of examples of these are, one are mathematical sentences. So use a symbol here. You have 10 is less than 20. So the less than symbol, you know that when you see that, that stands for less than. And then another mathematical sentence are, there are 3 times as many pencils as pens. And then some conditional sentences, like if 10% of a number is 15, what is 50% of the number? So these are just things that come up in math specifically. And the way that they're written is important to how you solve the problem. And then one of the main functions of syntax is to organize language to convey meaning. Again, if I were to say, here I have 10 is less than 20, but you couldn't switch that around and say 20 is less than 10 because that would be false. And the last language demand is mathematical precision. So basically just being precise and accurate with definitions and symbols in labeling, measurements, and numerical answers. And a couple of examples of these are correctly labeling the axes of a graph. This is really important because there is a specific way to do it, and if you don't do it that way, then the problem that you're doing isn't going to make sense. It's not going to be right. And then specifying units of measure during calculations. This is always a big thing that I've always seen in school. It's always important that once you find that answer, you want to make sure that you specify the units, because one unit could be very different from another unit. And if you don't specify, the person that is looking at the problem, trying to understand it, isn't going to understand it. So those are the language demands and academic language as it is important to the EdTPA and just in general in the classroom.